Welcome to the Above and Beyond. Here today we are going to talk about the technology, what are the challenges to build the system and how the system works in different terrain. So my first question to which game? Who's ready for a
DC or
rapid?
Avengers?
I can go first. So
Yes.
shoot.
Okay, cool. So the first question, can you explain the core technology that differentiate between SWIN's drones from other players in the market?
I think the real difference is the level of autonomy we're talking about. One,
1 second. Maybe I'll ask a lot of stupid questions, please. What do you mean by autonomy?
so I mean, nowadays you see a lot of drones, they fly by themselves.
Alien is flying?
Alien is flying. So you have the little alien on board guiding it.
Okay.
But of course, that alien has different capabilities. One can maybe fly in a really flat field. The other one can do a crazy parkour. So a lot of drones out there, they claim they have autonomy. They do have autonomy. They can fly by themselves. But the problem is they can only do it in very simple scenarios.
Please explain what type of scenarios.
So, as in the previous podcast mentioned, what Kunal said is, for example, in Paddy, completely flat, no real obstacles in the way. It's a very simple scenario because the drone basically just has to do exactly what it was pre-programmed by a human to do. So you give it a grid, it flies it, it kind of relatively follows the terrain good enough. But then if you put that same drone into, let's say, a tea plantation that is on a steep terrain, there's like every 5 meters there's a tree where it has to navigate around. Maybe GPS is a little bit sketchy, and it still has to, by its own, do these missions. Most of these systems fail. And this is actually mostly because these systems are not, number one, designed for it, but they also rely on a very simple sensors. For example, most of them rely on very simple radar systems. So they can just basically tell you, okay, there's something big, maybe like 5 meters in front of me. Or the ground is roughly 5 meters below me because it's nice and even.
Is it like how Tesla system works the car like that way? Like, okay, it knows, okay, some obstacles is coming, then it tells you, okay, let's avoid this.
Yeah, this is, I would say, okay, comparing ourselves to Tesla, this is of course a bit clap on the back, so let's not go all the way there. But this is a bit basically how our system compares to maybe some of those old cars that could potentially maybe keep the distance to the car in front of it, but you still pretty much had to steer the entire time. But a Tesla, you legally have to, but in theory you don't even have to touch the steering wheel. There were people sleeping in the cars for an entire hour while the car was driving, and the car did everything by itself. So I think this is the difference between the products we're talking about. One, where the pilot really has to make sure he's constantly watching it, intervening, works in very simple scenarios. And the other thing is that does it all by itself.
The idea is to have a system that works for this kind of the kind of farms that we have in India and Indonesia, and like it's not just Indian farms. Absolutely, I spoke about rubber previously as well. India is the fourth largest producer of rubber. Largest is Indonesia, for example. So, just the system is applicable throughout the globe. Um, and I did speak about the complexity of terrain. When I say that, I mean how does the crop look like? How does rice differ from rubber, for example? Rubber is a complex terrain. It's a spraying drone like Bumblebee has to maintain the distance from the crop for the spray to be effective.
Maximum height of a tree is this.
Yeah.
Maybe the bumblebee can go here and just fly and spray it.
But the next tree, the next bunch of trees are actually 10 meters lower than this one. So
So that is okay, no?
the spray will completely drift to
Oh,
a different location.
okay.
You have to release the spray from roughly the same height for it
Okay.
to be effective. It will not go down to the bottom leaves otherwise. Let's give a much simpler example of cars. So a car can be autonomous if it is driving in an open field. It just has to go from point A to point B. Right? The moment there are pedestrians and streets and traffic lights and you have to respond to all of that, you need a whole different level of autonomy, right? So that is how Bumblebee differs from other systems. The other systems are like that car which is driving in an empty field, no trees, no pedestrians, no buildings. It just has to go from A to B, and it will somehow get there, right? That's autonomy, but much simpler to achieve. Um, and then there is the second example: car driving in a city, in a busy street, with pedestrians, with other vehicles. With it has to respond to traffic lights. It has to follow traffic rules. So imagine the level of complexity it's there. I mean, Tesla is Tesla for a reason, right? So that's why that is how Bumblebee differs. It is a whole different level of autonomy, and that is not currently there in agriculture in most markets globally. So in most markets where we plan to introduce Bumblebee, it's one of its kind.
What are the challenges did you face in developing this sort of technology?
Today, everyone has a basic level of understanding of technology, but people who are not involved in technological development is that technology development takes time. There are no shortcuts, right? And that is the reason. If you want to build a good product, it is challenging. There are setbacks.
If you see most of the startups or other tech companies, they use AI and machine learning. So is it actually, do we have any AI or machine learning thing going in the backend, or just like, okay, again, a jargon being used just to fool people?
I think nowadays AI is thrown around quite widely. I'm currently with ChatGPT, the big buzzword coming out in everything. Most people just think of AI as this. It's like this basically tool that can talk to me. But I mean, what does AI actually stand for? It's artificial intelligence. So a robot that can interact with its environment, that can react to external stimuli, to situations, make decisions on its own. This is what AI is considered. And in our system, we definitely have AI. We have neural networks in there. So teach a machine with data. You put a lot of data in, and then the
So
machine
where
itself,
do you get this data from?
the real world,
Okay.
simulation.
You did ask, right?
Yeah, you
what were
wanted
the
to-
challenges? What were the challenges in
Yeah.
building? These are the challenges.
Yeah, where do you get good data? So you have to, some of the aspects are like you want to teach the robot for specific, like agriculture, very specific use case, very different than, let's say, mining or inspection. So you want to teach the drone.
We are at a juncture where quantity doesn't matter. It's the quality of data that matters. And just to clarify, not everything that Bumblebee does uses data or neural networks. There are some conventional algorithms as well in there. But talking specifically about the data driven part of it, when I say data driven, it's the AI that has been trained on data, right? Very important. AI does not have does not have a consciousness of its own. It's data driven. So what you teach and how well you teach it will decide how well it responds and makes decisions in real life. Luckily nowadays there are methods, there are libraries, there are tools to what we call data augmentation. You can augment the data. You can take the same image, for example, and make it look different in 100 ways.
So is any fail system embedded in the Bumblebee? Like, okay, for example, if there's no signal, will it come back to the starting point or other algorithm that you have programmed?
I would say safety for us was one of the cornerstones of the development. And with this in mind, pretty much every system in the drone has its own kind of failsafe. So let's talk about obstacle avoidance. So it was actually one of the first thing we developed for the drones, because you fly in a field, there's trees, there's power lines, there's people, there's cows, anything. So you want to make sure the system can avoid it. You want to be able that this happens efficiently and safe, it doesn't collide. But if you have one system, and even if it's 99% efficient, there's still always a chance that it fails. So better put a second one in, then they can work together, and the likelihood of failure is a lot lower. Then for landing, for example,
One second, before you go to the landing, will you do a drone test, like Bumblebee is just coming at you and just like, okay, see like, okay, it will hit you or not? Are you ready for that challenge?
We do that all the time.
he has been the test dummy hundreds of times.
So my official designation in SUIND is CEO and test
Obstacle.
obstacle.
He is our pole. Yeah.
Yeah,
No,
so absolutely, like that's one of the advantages of using the vision-based algorithms that we specialize in. For example, like in farms, the most common obstacle is twigs and branches from a tree that is just on the corner, but it is sort of hanging into the field, and the system is able to detect that with that kind of granularity. So that is what we mean when, like, you have to build a product for a particular application and you have to make sure it is good at it. That's the philosophy that we followed. So yes, absolutely, I'm up for the challenge. Are you up for the challenge?
Let them do it first, then I'll do it.
If you talk a bit about really believing what our system can do, I would invite all the viewers or anybody who's maybe interested in getting one of our systems, seeing it in action, coming to one of our demos. We regularly do showcase the system. They can see it in action. They can have us being the obstacles. They can be the obstacles themselves. We actually just give the remote controller to people to see how easy it is to use, because we've talked a lot about like the features of the whole product. So like obstacle avoidance, terrain following. We have a lot of like landing features, safety features, etc., etc. So there's a lot going into a system to make it a complete and cool product. But why do we do this? Why do we pack it full of these features and safety tools and everything? The key aspect is we want to make it really easy. If it's super safe to use, it's easy. You can't really do much wrong.
So you're saying anyone can fly?
Our vision is really a grandma can fly the system. That is our future
Try it
goal.
out. I'll try it out.
No, it's really, I mean, this is what it should be. Like, you have a remote controller. Right now, you still need a pilot license. Let's see, maybe in a couple of years, if we showcase this autonomy, this might go away. But you basically have a smartphone, tablet, and a remote controller. You select the field you want to fly, you press start, it does its job. You don't really have to do anything else. And all the nitty-gritty complicated stuff that a pilot would normally need to do or handle, or that you might need to program in it on another system, it's just handled by the system itself. And you also don't have to worry about the safety, because, oh no, like, there's an obstacle in the field, I didn't mark it. In our system, you don't even mark it. It flies around it. You don't have to worry about it.
Interesting. Right now we are talking everything about vision, but core vision is the sustainability. Does it use like less amount of pesticides? So how our system is unique, and how is it like reducing the amount of the pesticide that is used by the farmers?
That definitely, like, it's a great question, because ultimately it's an autonomous system that can spray on complex terrain and blah blah blah, but it's a spraying system at the end, right? So the real saving, or the real reduction in pesticide usage comes not just using the sprayer, right? So a spraying system is replacing the job of manual spraying with drone spraying. It can save 15 to 20% of chemicals, just because the spray application is a lot more precise now. You don't waste anything. The mechanics of the spray going in is a lot better, so the effectiveness is a lot higher. In fact, we have examples where just by using the sprayer, we were able to reduce chemical usage by 50%. But that was not because the sprayer did anything special. It's because the way it is done otherwise is so inefficient, and the manual methods are so inefficient. But there is more beyond this. So there is this whole domain of crop analytics, where you can actually, instead of spraying the entire crop, whether with a drone or manually, doesn't matter, you're still drenching the entire crop, right? That part you can do more precisely. So where the crop is more stressed, you target the spray into that area more, and rest of the area gets a basic like small dosage. And that is where you can go to like up to 90% in chemical saving. There have been numerous studies which has shown that 70 to 90% saving is possible, but it's all about the right decision making and how we make those decisions. What are we working on in that domain? We'll talk about in.
Using our spraying drones, there's multiple aspects where you can really save in the inputs into the field. So of course, chemicals, as I mentioned in one trial, we had 50% savings across the board. Saying 30% saved in chemicals is definitely not an overstatement. Sometimes even more than 50%. But if you talk about like tractor spraying or those like knapsack sprayers, of course, you have to power them. So they need a lot of gasoline to run, which is normally used. So a third to a half of the cost for the operation of the spraying for a farm is actually often the gasoline that goes into these machines to just power them. A drone, on the other hand, is a lot more efficient. So even if we are like in a remote field, you don't have a power outlet. So in that case, maybe not 100% green, but you still run a generator because the drone itself operates so much more efficient. You don't have to, for example, in rubber, they spray from the bottom up 30 meters high. So imagine you have like a garden hose and you want to spray a 30-meter high tree from the bottom up and you want to reach the top. This is not really working so well. So number one, most of the water, or in the case of spraying chemicals, actually ends on the ground, making the ground go bad, huge wastage. But also, if you want to get that compound up there from the ground, you need a lot of pressure. How do you build pressure? You have a big compressor, basically with a big engine that just pumps in gasoline to push it up. So there's huge amount of petrol being wasted like this. And drone, you fly above, you spray it down,
And
a lot more
maybe
efficient.
to add to that point, you don't get laborers also like so easily at present. Like that is also a challenge where like okay, farmers are trying to get a hey, help us like do this part of the spraying and all that. Our system is like completely autonomous and requires maybe one or two. Like how many
Yeah,
people?
I would say maximum two people, but
It's two.
one
Yeah.
person is more often than not enough actually, because I think yes, this labor problem gets talked a lot about. Obviously, as Kevin mentioned, in the West, it's a no-brainer. Labor is very expensive. People don't do these kind of jobs. Um, in India as well, like it's a big misconception, I think, and I get this from a lot of Indians, but also a lot of Westerners that, but labor is really cheap over there. Like, why would they automate? Why would they do this? My take on this is it's labor is definitely not. It's getting expensive. It is comparatively cheap. For example, if you compare North India with South India, you already see a difference in the rates. Uh, but we have to understand that we live in a different world today. People have a lot of job opportunities outside of agriculture, and they don't necessarily want to do the hazardous jobs anymore, right? So it's not so much that like people are available or not available. It's that people just have more options now, right? So the second side of this whole thing is, um, and this gets asked a lot. I mean, if I had a rupee for every time I got asked this question, it probably wouldn't be need to raise money ever. That is it even needed in India? Is it even needed in developing countries? Like you have small landholdings, yes, those challenges are there, right? But we need to build systems around that. But more than that, when we talk about climate change, when we talk about sustainability, these are the farmers who are going to suffer the most, not the already mechanized, wealthy Western farmers with huge farms. They will suffer as well, for sure. But a farmer in India would probably lose the entire livelihood, right? So it's the need, it's the urgency. I, if you remember, I said in the beginning, like agriculture deserves the best of tech. That's what I actually mean by it. Like let's not treat it as a wealthy economy, a wealthy farmer versus a poor farmer problem. It's a need. The poor farmer's need is a lot more. There's definitely a lot of things have to be figured out in these kinds of economies, but we need to find solutions around these problems, not just say that yeah, this will not work in India, because that's not what we have experienced. It does work. It works very well, and um, Indian and other farmers definitely deserve the best.
Yeah.
True.
Just adding to this, the deserving aspect, of course, is super important, but for people, of course, they want to deserve, but they have to afford it. So this is actually the second part of the question we always get asked, like, especially for me, if I'm, for example, talking to people in like Europe, it's like, you're doing this in India, can people even afford your systems? And the really cool answer, which I always like to push back to them, is absolutely, it is actually cheaper option for them. So it's not just that we are giving them a really expensive option because they don't have something else. Even if they could afford or they could find the labor, actually, using our system is the cheap alternative. because it's so much faster. You save so much chemical, so much gasoline. It just makes sense for them, and I think this is a cool way in how any system that wants to create long-lasting impact has to be. It is not just more sustainable, but it is more cost effective. And it is actually more sustainable because it is more cost effective, because you save so many compounds. So this is the really cool interaction of the system with the market. And then again, if it works in India with the labor charges here and the costs over here, it will pretty much work in the rest of the world as well.
Interesting. So on that note, like, if you want to try out our system, Bumblebee, there is a link on the description. Just fill out the form, and our team will get back to you. Uh, Going to the last question for this episode, what do you think about the vision, like the long term, 5 years or 10 years? What do you think about the drone technology in the agriculture aspect?
Um, yeah, that's a very interesting question, and I would say um, it's an evolving area. Drones are just coming into agriculture. They have a lot to say, have a lot to contribute. So you will definitely see this evolving. What we think, where we think this is going is, as I touched upon earlier, definitely this next thing that we are working on. Um, right now, you do see a lot of spraying happening with drones, right? You see a little less of analytics happening. But I think analytics is a much bigger space. It's a much bigger market in general, and it will have a much bigger impact on agriculture as a whole. So analytics drone in tandem with the sprayers is going to be the ultimate solution. Is going to be I won't say drones will be the only ones contributing to this. Of course, ground-based sensing and satellites and all of that will combine into the system. But I'm more talking from SUIND's perspective, where we can contribute. And that is definitely in this extending just spraying into the analytics domain as well.
That was like an information overload of technology and the challenges that we faced. But stay tuned, there is more coming that we are going to talk about the impact, the case studies, what happened in the real life world. For that, you need to follow, subscribe, and hit the bell icon.